Good afternoon, students. Welcome to Analytics Powered Virtual Interactive Classes. So, how are you all? Hope all of you are doing great. So, today we are going to discuss a new topic. Okay, so the chapter we are going to discuss the next part of this chapter. Okay, but today's class we are going to start our class by observing one activity today. Okay, so are you ready? Very good. So let's start. Let's see what's there in the screen. There are two beakers, and inside the two beakers there are water. Okay, so in the first case there is this small ink bottle, and with the help of a dropper we took some ink and we are now dropping those inks into the first beaker which has water in it. And see what kind of changes we can observe here. We can observe that the ink droplets, they are gradually getting dissolved in the water, isn't it? See, after some time we can see that the ink droplets, they are gradually, like completely getting dissolved in the water. Similar to this, in the second case there is this small ball of honey. Okay, and from that we took one spoon, and with the help of that spoon we poured some honey in the second beaker. And now with the help of one glass rod we are now stirring the mixture, and after some time what we can observe, that the honey, it is also getting dissolved in the water, right? So in both the cases, ink and honey, they are no longer visible separately in the beaker, isn't it? See, in the first case we can't clearly separate water and ink, and in the second case also we can't separate honey, which one is honey and which one is water, right? So ink and honey are no longer visible separately in the beaker. Clear, everyone? Similarly, if we try to dissolve glycerin and vinegar, they also will show this kind of property. What is it? That they will also get dissolved in the water. So from this we can say that all these things like ink, honey, glycerin, vinegar, all of these, they are soluble in water. Okay, so next line is, similarly glycerin and vinegar are also soluble in water, right? So both all these things like honey, ink, glycerin, vinegar, all of these, they are getting dissolved in the water, isn't it? So from that we can say that they are soluble in water. And see, there is next case where there is one bottle of oil, and from that bottle we are pouring some oil in the beaker which has water in it. See what kind of changes we can observe in this case. See, the water is on the bottom, and the oil which we are pouring from the bottle, it is preparing two layers, right? And even if we want to mix them, like the water and oil, if we stir them and try to mix them, still they won't get mixed together and they will form two separate layers, isn't it? So the mustard oil forms a layer on the water. See, there are two layers we can observe clearly, right? One layer, it is layer of water, and the second layer, it is the layer of oil. Two separate layers are there, isn't it? So mustard oil or any kind of oil, it will form what? It will form a layer, a different layer on what? On water. So from this we can say that it is insoluble in water, isn't it? It's not getting dissolved in water completely, right? It's all like separately it is making another layer. So from this we can say that water is not able to dissolve oil in it, right? So oil is insoluble in water. Clear everyone? Very good. So from all these observations, we can conclude that there is one table here, small table. One side there is contents like which kind of objects we are trying to dissolve in water and what we can observe. Okay, so in the first case, glycerin in water, if we mix glycerin in water, what will happen? It is soluble in water. Then mustard oil in water, will it get dissolved? No, right. So from this we can say that it is insoluble in water. Clear? Then vinegar in water, it is what? Very good, soluble in water. And honey in water? Very good, it is also soluble in water. Okay, clear everyone? So now there is another case here. See, there is one fish and it is taking some gases from the water. So they are also like the animals who live in water, they also have to take oxygen, right? So how they take it? Like in our case, what we do? We take we through respiration, with the help of respiration, we took oxygen from environment, isn't it? But animals which live in water, how they respire, how they take their oxygen? See, some gases are also soluble in water. Okay, oxygen gas dissolved in water is taken by aquatic animals. So the animals who live in water, also known as aquatic animals, they take or they collect their oxygen for respiration from the dissolved oxygen or the oxygen gas which is dissolved in water. Okay, so some gases they are soluble in water like oxygen. Okay, so the oxygen gas which is dissolved in water, from that oxygen aquatic animals are able to collect their oxygen for respiration. Clear everyone? So here comes our first question. So let's see what's the question is. So question 1 is, when sand is added to water, which of the following phenomena is observed? What we can observe? 4 options are there. Option A, sand dissolves in water. Option B, the color of the water changes. Option C, sand settles at the bottom of the water. Or option D, sand float on water. Which one will be the right answer? I am giving you the timer. Try to answer everyone. When sand is added to water, okay, if we try to mix sand with water, which of the following phenomena is observed? What we can observe? Will the sand dissolve in water, or the color of the water will change, or the sand settles at the bottom of the water, or sand float on the water? What will happen? I am extending the time. Try to answer everyone, okay? What will happen? Wow, so many of you have given the right answer. Very good. And with that, your time is up. Let's see how many of you have given the right answer. Very good. So, let's discuss the question, okay? So, as we know that sand is insoluble in water, right? So, if we mix sand with water, they won't get dissolved in the water. So, after setting it up for a certain period of time, what will happen? The sand will gradually settle on the bottom of the water. Okay, so the answer or the correct answer will be option C, sand settles at the bottom of the water. Okay, clear everyone? Very good. So, next we will be observing one small story. Let's see. See, there is this beautiful house here, and in front of the house, what we can see? Right, there are some chairs which is present in the front of the house, isn't it? So now there is one boy and his mother. They are talking something. Let's see what they are talking about. So now the boy is asking his mother that, Ma, how can I help you? Now his mother is telling him that chairs are lying in the asan outside. Keep them inside or bring them inside. So he went to take those chairs inside, right? So he collected the first chair, then he went to take the second chair. But this time he felt that the second chair is a bit heavy. Okay. So now he is telling that bamboo chair was lighter than iron chair. So the first chair he brought inside was made up of bamboo, and now this chair, it is made up of iron. So by collecting both the chairs, he observed something. What he observed? That the chair which was made up of bamboo was lighter compared to this one which was made up of iron. Okay, so from this we can say that heavier objects has more mass. Okay, the objects who has more mass will feel like they are heavy, and lighter objects has less mass. That means the objects which we feel that they are lighter, that means they have less amount of mass in them. Clear everyone? Very good. So now he is telling his mother that, Ma, I want to test something. He wants to test something. Let's see what is he wants to test. Okay, his mother permitted him. Let's go. Go for it. Do. So now he took one jug of water, and from that he started to pour some water into a glass. And there is this another glass which is empty, right? So in his one hand there is one glass which is full of water, and another hand he has one empty glass. So who can tell me which one will feel heavy? Best glass which has water, right? So empty glass will feel lighter, and the glass which has water in it will feel heavy. So similar to this, his mother is asking him that, what do you feel? He feels that the tumbler filled with water is heavier than the empty one, isn't it? So from this we can say that this means that water also has mass, as when we are pouring some water into the glass, after that it is feeling heavier. That means it is heavy means what? It has mass, more mass, isn't it, compared to the one which is empty. That means which one that doesn't have water has less amount of mass compared to the one which has water in it. So from this we can say that water also have some amount of mass, isn't it? So now we will observe one very interesting activity here. Okay, so there is this one weighing machine, and there are three cups, paper cups A, B, C, as we can see here, and there are various kinds of objects which we will be weighing now. So in the first case, there is this paper cup named as A. So its weight is almost 8 grams, and after tearing it, now we will be pouring some water into the first cup. See what is the weight of the water or the first cup? Very good, 50 grams. Now in the second cup, like the cup which is named as cup B, we will be observing turmeric powder. The weight of the turmeric powder we will be measuring. Okay, so in this, all these cases, okay, so we are measuring the mass of those objects. Okay, so first we observe the mass of water which was 50 gram. Then turmeric powder, the mass is now 75 gram, like we are measuring their mass. Okay, and in the third case, like the cup which is named as cup C, we are measuring the mass of some tiny stones. Okay, so in this case After pouring some stones or rocks inside the cup C, the mass is what? The mass is 100 grams, isn't it? So, now who can tell me which one will have more mass? Like the cup A, cup B or cup C, which one has more mass? It was 50 grams, it was 75 grams and it is 100 grams. Which one has more mass? Very good, it's very easy. 100 grams will have more mass. Right. So, everyone note down that an object is heavy or light. It can be expressed by a property called mass. Okay, so the mass we are telling about is what? It is the amount, like how the object is feeling light or heavy. Okay, so if the object is heavy, that means it has more mass, and if the object is feeling light or lighter, that means it has less mass in it. Clear, everyone? So here comes our next question. Let's see what the question is. So if an object's weight increases, its mass. If an object's weight increases, its mass. Option A, four options are there. Option 1, option A decreases, option B increases, or option C remains same, or option B none of them. If we are increasing the weight of some certain product, will its mass increase or decrease or remain same, or none of them are correct? I am giving you the timer. Try to answer, everyone. Try to remember the last activity which we have discussed. Okay, so what happened? When we increased their weight, what happened? Did their mass also increased, or their mass decreased, or their mass remained same, or none of them are correct? Try to answer, everyone. Okay, I am giving you more 15 seconds. Answer, everyone, try. What happened? What we observed? Whenever we were increasing the weight of that object, was its mass increasing or decreasing, or it remained same, or nothing happened? None of them are correct. Okay, your time is up. Let's see. Very good, very good. So many of you have given the right answer. So let's now discuss. Okay, so whenever we were observing that whenever we are increasing the weight of that object, it is getting heavier, isn't it? So from this we can say the object, like we have studied earlier also, there was one line, the object which is more heavy, that means it has more mass, right? See, I am writing again, the object which is more heavy, that means it has what? It has more mass, isn't it? So if we are increasing the weight of that object, that means it is getting heavier or lighter? Very good, heavier, isn't it? So that means from that we can say that if the object is getting heavy, that means it is having more mass, isn't it? So from this we can say that its mass, it will, very good, increase. So our option is increases. Option B, increases, will be right. Clear, everyone? So if an object's weight increases, its mass also do what? Very good, increases. Okay, so next question is, let's see, which of the following object has the lowest mass? Okay, see, there is one simple trick. The more heavy the object will be, the more mass it will have. The less the object will be, the more the object is lighter, the more its mass will be less. Okay, that means more heavy, more mass, less heavy or lighter, less mass. Clear? So which of the following object has the lowest mass? Is it option A, stone, option B, wood, option C, cotton, or option D, iron? So I am giving you the timer again. Try to answer, everyone. Okay, so which of the following object has the lowest mass? Option A, Stone, option B wood, option C cotton, or option D iron. Which is the right answer? Tell me, try to answer everyone. Which one is it? Which one has the lowest mass? What do you think? Okay, I am increasing the time. Okay, I am giving you extra 15 seconds. Try to answer everyone. Okay. So which of the following object has the lowest mass? Which among these four options will feel lighter? Is it stone or wood or cotton or iron? Okay, with that your time is up. Let's see how many of you have given the right answer. Very good. So many of you have given the right answer. So let's discuss. See, if we take one piece of stone or wood or iron, all of them will feel heavy, isn't it? But instead of these three things, if we take one piece of cotton, it will feel lighter compared to all these three, isn't it? So from this we can say that the lowest mass, the object which has lowest mass will be cotton. Okay, so lighter means what? Lighter means less mass, isn't it? Heavier means more mass, lighter means less mass. So cotton, it will be lighter compared to stone, wood, iron. So, from this we can easily say that less mass, the object which have less mass in it is cotton. Clear everyone? Very good. Now, next we will observe one class situation. See, the madam entered their class and they are greeting, good morning ma'am. Now, the teacher is telling them, good morning everyone. Let's do a quick activity to start. So, they are also starting their class with a small activity. Let's see what the activity is. So, I need two students to please come to the front with your water bottles. So, now she is calling her two students. Any one of them can come in front of her and they have to bring their water bottles. So, two of them went in front of her desk or table with their water bottles. Now, what is she instructing? That now carefully pour some water from your bottles into the two glasses or tumblers. Okay, so let's see. Now they're pouring some water into the glass tumblers from their bottle. Now see, in the first glass, the glass is full of water, and in the second glass, the glass is half. That means the water level in both the glasses is. So one student, she is asking that, ma'am, why is the water level different in the two tumblers? Isn't it? So one glass and second glass, first glass, second glass, both of them had two different layers of water. Why? Why is it happening? It is happening because now the teacher is telling, she is giving us the answer. So excellent observation. The levels are different because you poured different amount of water. So what they did, the students, both of them, they poured some water into the glass tumblers, but the amount of water they poured in it was different. The first glass, there were more amount of water, and in the second glass, there were less amount of water in it. Okay, so more water takes up more space. So, and we call that space its volume. So, volume, there is another important word here. Earlier we have studied about mass. Now we are going into volume. So, what is volume? The amount of space which an object is occupying. Okay, the amount of a space, certain amount of space which is occupied by a substance. See, you are sitting somewhere, isn't it? And you are occupying certain space. So that means the space you occupied is your volume. Okay, so every matter present, every substance present in our surroundings, they are capturing certain amount of space. So the space which they are occupying is known as its volume. Clear? I hope everyone got it. So what is volume? The amount of space which an object is occupying is known as its volume. Clear everyone? Very good. So now one student, she is thinking something, that why was I not able to transfer water from the jug into an empty water bottle completely? Now I know the reason behind it. Why? Because the volume or the capacity of that bottle, it was limited. That means it was able to hold or store certain volume of the water. And when that volume filled up, that certain amount of water captured that space, the extra amount of water, they got spilled out. Okay, see, I hope the thing we have discussed now you have understood. Okay, so next let's see our next question. What is it? The amount of space an object occupies is called its dash area. The amount of space an object occupies is called its dash area. So four options are there. Option A, mass. Option B, volume. Option C, range. Or option D, density. I am giving you the timer. Try to answer everyone. Just now we have studied it, right? So the amount of space which an object is able to occupy is known as its what? As its, is it mass? Option A. Option B, volume. Option C, range. Or option D, density. Which one is the correct answer? Try to answer everyone. Very good. So many of you have given the right answer. Rest of all, you also try to answer, okay? And with that, your time is up. Let's see. Very good. So many of you have given the right answer. Very good. So, our correct answer will be option B. The amount of space or the space which is captured by an object is known as its volume. So, our right option will be option B, volume. Clear everyone? Very good. Now there is another activity, small activity. Let's see. So there is one glass of water and in the hand of the teacher there is small tiny lemon here. So whenever she is dipping that lemon inside the glass filled with water, some water is spilling out of that glass. Okay, so the now student, her student, he is asking that why did the water overflow when the lemon was dropped in the tumbler? Can anyone tell me why these things happens? Let's see. Because lemon occupies some of the space inside the glass. See, as we have already discussed that every substance or every substance which is present in our surrounding, each of them have certain amount of volume, isn't it? So similar to this lemon here, it also has certain amount of volume, isn't it? So the volume which the lemon has, it is capturing the space inside the glass. So naturally the water which can't be fit or stored in the glass, they are getting overflowed. Right, so because lemon occupies some of the space inside the glass, that's why the water is overflowing from that glass. And in the next phase, we can see that the teacher is pouring water, extra amount of water in the glass, and the water which the glass can't hold, they are getting overflowed from that glass. So now the student is asking again that why did the water overflow from the tumbler? So the answer is because all the space inside the tumbler is occupied by the water. So the extra amount of water which is not able to be there in the glass, they are getting overflowed or spilled out from the glass. Clear? So that's why the glass is overflowing. So the space inside the tumbler is the volume of the water. Clear? The space inside the tumbler is the volume of water, the amount of water the tumbler is able to capture or store is the volume of the water present inside the glass. Clear? Now comes our next question. Let's see. If the volume of an object increases, what happens? Option A, its size increases. Option B, its color changes. Option C, its weight decreases. Or option D, its shape decreases. If the volume of an object is increasing, okay, what happens? Option A, its size also increases. Option B, its color changes. Option C, its weight decreases. Or is it option D, its shape decreases? So I am giving you the timer. Try to answer everyone. Okay. So we are increasing the volume here. So volume was what? The amount of space which one object is able to capture. So if we are increasing the volume, what will happen? Will the size also increase? Or its color will change? Or their weight will decrease? Or its shape will decrease? Okay. So try to answer. Okay, I am giving you extra 15 seconds. Okay. Everyone should answer it. And I can see so many of you have given the right answer. Very good. And your time is up. Let's see how many of you have given the right answer. Very good. So many of you have given the right answer. Very good. So, volume is increasing. That means what? The amount of space that object is occupying is also increasing. So, similarly, from this we can say that the size is also increasing, isn't it? See, something which is smaller in size, they are capturing small amount of space. See the example of pen. Your pen, it is taking less amount of space compared to your book because its size is bigger than your pen, isn't it? So similarly, the volume of your book will be also what? More than the volume of your pen, as the book is capturing more space than the pen, right? So if we are increasing the volume, that means its size is also getting increased, isn't it? So our correct option will be option A, its size increases. Clear everyone? So from today's class, we were able to know about two new things. What was that? One was mass and second was volume. Okay, clear everyone? So that's it for today. I hope whatever we have discussed in our class, all of you understood that. Very good. So till then, stay happy, stay healthy. Bye bye.